Hello and welcome to another edition of Test Gear Tuesday. Today's edition we're going to demo this Sinometer VC2000 frequency counter. This is badged under a lot of other names. You know them, you've seen them, and you've probably always wondered about them. Well, wonder no more. Although you've probably seen other videos. Here's my contribution to the world. I have owned this frequency counter for about 5 years. I bought it off of eBay. I bought it, I got it, I tried it, it didn't work. Had issues. Half of it worked, half of it did not. The lower spectrum from about 30 megahertz below worked fine. Above that, band A did not work. Only band B worked. Kind of bummed out about it. I contacted the seller. He lived semi-near, about an hour away. I drove to his house. He put it on his workbench. Caveat to that was he worked on vintage aircraft gear. He opened it up, looked at it, poked at it, put the cover back on, put the case back on, and he said, well, I can't figure it out. What if I refund half of your money? I thought, well, okay, it's not exactly what I want, but it is better than what I have. So I went ahead and took it. I used it for some time, and I've been very vocal about my disdain towards this frequency counter, and we'll talk about that in a moment. Used the frequency counter until I upgraded, and I eventually sunsetted the frequency counter. Every once in a while I'd pull it out and dork with it. This last time I did that, I found that more problems had accrued. It would no longer go, I think it wouldn't go any higher than about 15 megs or something like that. Definitely fell short from where it used to go. So I got a little curious and wanted to fix the dumb thing. At that point in time in my brain, I wanted to try to achieve in fixing this. Tore it apart and started learning everything about the components that I could, you know, all the ICs. And from what I have learned previous in educating myself on frequency counters and synthesized RF generators, things of that nature, learned about Prescaler, so that was the first thing I wanted to look at. Pulled the Prescaler, well, I tested it in line, I couldn't get anything, so I thought, well, I'm on the right track. Unfortunately, I had to order the Prescaler from China, and I had to wait a couple of months for that to come in, so back on the bench it sat. Tore it apart and went straight for the Prescaler. I bought 5 Prescalers, and the Prescaler in question is a MB506, and it's good for a 2.4 gigahertz frequency, which is super duper cool because that's exactly what this unit calls for. The frequency spectrum on this is from 10 hertz all the way up to 2.4 gigahertz. Again, I never achieved anything above 30 or 50 megahertz, so anything above that, fat and happy with. I went ahead and troubleshot my path from my ports, confirmed my ports here worked, and confirmed all the wiring and traces and every single component between here and the Prescaler did indeed function and pass signal like it was supposed to, and it did. Went ahead and put in the new Prescaler. Shazamo. The thing came to life. Very, very exciting. First time I'd seen band A come to life. So I went ahead and did some quick tests before I reassembled it. Fat and happy with what I saw, reassembled it, and then I went ahead and tested it. One other thing I did before reassembling the case, the reference crystal. This works on a 12 megahertz crystal. I tore it out of its case that you could see here in the photos. This is in a heater environment, so that is very good. A lot of people had issues with these being hot mine are not hot. And see, or I'd be shocked. Checked it out with scope and voltometer. There's no voltage going there whatsoever. They are properly grounded. Power supply is properly grounded. Everything, shielding, everything is properly grounded in my unit. I'm happy with that. The crystal, I pulled the crystal out and I checked it, and it was just fine. Put it back in, and then I calibrated the crystal to calibrate the frequency counter, and I applied some more duck butter on the crystal and pieced it all back together. That way we got good thermal and everything. Had to, because I had to wipe it all off anyway, the old stuff. As stated, got it going. One of the ranges does not work. It's completely dead, but it does work. Now, I sat here today and I did a truth table up. Oops, sorry, I bumped the camera. I'm not going to go through everything that all my tests that I've done. Get my fingers out of the way. So that's my truth table. We'll hit a few of these key points. I did this for range 3 and range 1. Range 3, I was able to use my B&K multi-function generator and successfully run through all the tests as needed. Once I went to range 1, I had to switch over to my HP 8660C RF function, my RF generator. I don't know why I started to say function generator. And I completed the test out on that. Also, let it be known that with the B&K, I also did RF testing on this as well. Again, I'll throw up all these numbers on the screen so you can pause for the cause and soak all the glory in, I reckon. So if you've got one of these, you can compare it to yours and see what's happening. Or just out of GP, want to see how well it did. Right now, what we have it plugged into is port B. This is range number 3, and per the specs, this covers 10 Hertz through 50 megahertz with a range of 10 millivolts to 80 millivolts, and the port has a 30 volt input maximum. In my testing on sine wave, like I said, right now I have this on a 10 meg reference, which is coming from my HP. Let me go ahead and break that, and let's go ahead and get this set up for the test. Now, the first test we're going to do, the minimum I was actually able to get this to read was at 100 millihertz. That's right, millihertz at 4 millivolts. So let me punch my 4 millivolts in and swap that over to 0.1 hertz. Now, next thing I need to do is I need to change my gate time on this. By changing my gate time, that's going to change my resolution, where I have more resolution. And you see here we are on the kilohertz frequency. And while this is counting down the 10 seconds for it to grab the frequency and stabilize. Make sure I am. Oh, that would make good sense why that's not working. Let's try that again. Okay, while that's counting down, let's go through some things. As you see, we do have 2 ports. Factory spec is port A is 50 to 2.4 gig. B port is 10 hertz to 50 megahertz. Both of them are B and C connectors. We have a crystal oscillator. Our gate time, our range time, our run time, our reset, and you can test crystals in here. That's why we have a crystal oscillator, and we have our 1, 2, 3, 4, 5, 6, 7, 8 digit counter, and our associated LEDs, frequency count, kilohertz, megahertz, and oscillator. And I know one of my cables is bad. I don't know if this is the bad one or not. So instead of wasting more valuable time, let's go ahead and set that aside. Let's grab another cable. But you did see that it was reading 1 millihertz up until the time I bumped it. And there's our 1 millihertz. So this definitely does go beyond spec at the bottom of the band here. Again, minimum is 10 hertz. We're actually seeing 0.1 hertz. So 100 millihertz at 4 millivolts. And the minimum spec is reading 10 millivolts. So pretty awesome there. Next thing we want to do is we're going to hit a few key things. We're going to go ahead and go to 400 hertz. And we're doing 400 hertz because in the radio world, tuning up radio, that's one of your frequencies that you utilize. And on that is 17 millivolts. And I do apologize that you're not seeing the my multi-function generator to see me push buttons, but I hope you understand. I'm also trying to do this in hopes of trying to speed up the video. I'd taken a lot longer than I had so far, and I apologize for that. So there's our 400 hertz. Now keep in mind that the millivolts that I've come up with is the minimum that this frequency counter for the most part locked on or stayed stable, or as stable as it could plausibly get. So that is how I come up with the voltages. The paperwork that comes with the device does not give you a truth table, so I had to definitely make up my own truth table on this. So we got 400 hertz at 17 millivolts. Next thing we want to do is go to 18 millivolts, and then we're going to 1000, and using 1000 because that is so prevalent in tuning up radios and other electronic devices. So we definitely want to see what our reference point is, what you need to, like if you're working on a RF generator or an audio generator, now you can see what it is. The next number we're going to hit is 20,000. Now 20,000 was selected because that's the high end of human hearing. And again, we'll deal with your audio generator, and for that 20 21 millivolts is what I clocked in on that. And then the next one is 1 meg. And for that, 27 millivolts. I could do a wide shot that you would see me punching in the device. You probably won't see the frequency counter too swell, but let's go ahead and give that a shot. Let's pause. Well, that's what you'll be able to see. You'll see me punching in this, and you'll see it respond on that. Let me terminate my overhead light. That way you could see the frequency counter a little better. So we're at 1 meg. So the next thing I want to do is go to 5 megs. And my power on that is 500 millivolts. Turn my gate off. This way now it'll respond a little faster. And of course we know we use 5 megs because that's half of 10 megs, so you could get the harmonics off of a 5 meg. You know what it's for. Speaking of 10 megs, let's go ahead and skedaddle right on up to 10 megs. And for 10 megs, pretty doggone close. For 10 megs, I actually clocked in 250. Oh. Because I goofed up on what I was doing. Let me adjust my power, because I set my power to 500 for some reason. So power on that is 252 millivolts. So there we go. Now, my signal generator only goes up to 21.5 megahertz. Now, this is where we really, doggone it, I keep doing that. I keep pushing the wrong button. And there I just increased my power. So now let me go to 21 megahertz. And now, for this one, I had to completely increase my power all the way, which is 10 volts. And as you can see, the last digit is not quite where we want. I would be happy with this. I wouldn't use this frequency counter for lab grade precision stuff, but for ballpark or close enough stuff, I would be very fat and happy with this right here. But again, you're shoving 10 volts into it. So not everybody is going to have 10 volts to shove into a device. Most manuals, most references are set at 1 volt peak to peak. So at 1 volt peak to peak, I would comfortably say that on this here, you could do 10 megahertz at 252 millivolts. Of course, you could probably get up to 15 megs and be fat and happy. I don't know why I didn't test it for its maximum at 1 volt. But either way, I didn't, and I'm not going to waste your time trying to expedite this video. Now, I did test this also on on RF with my B&K multi-function generator, and instead of running through the settings on that, let me just go ahead and flash up the table right here. You could pause and you could see the differences between sine wave and RF is. Channel B is concerned, we don't quite hit the high end of 50 megahertz. You're hitting 20 megahertz comfortably, but hey, you make up for it on the low end. Band B is supposed to be range 2 is supposed to be in between 2 and 3, that little gap. We don't care about it because channel A, range 1, takes care of all of your needs. So for that, we push button, the range button, and you just keep pushing it until you come to where you want. And we want range 1, and then we hit run. I have my RF generator here on, and let me turn up the power. And so you see right there we have 21.5 megahertz. So on this device here, on the HP RF generator, the 8660C is in Charlie, I started the test out on this at 30 megahertz. And on 30 megahertz, I was actually able to get 0.016 millivolts to excite it. Alright. Now, have an analog meter on this, so as long as this is proper, then that's what it is 30 megs at 0.016 millivolts. Now again, to help try to save time, I'll throw the table up. You could see the frequencies and the voltage. The highest that I found that this would actually stabilize is at 2.56 gigahertz, and for that I really had to give it all the moose juice that I could give it. Could not achieve the 2.4 gigahertz. The highest I was able to get this to go before complete collapse was 1.263 .8. And of course now, while I'm doing this, it's saying, no you didn't, fool. Oh, there we go. Yeah, there we go. We got it. So, I know you can't see it at your angle, but 12638.Z, and that's pretty much what we have it here. I would say I would use this as a reference just so you can see that the thing is working. Keep in mind the feed line that I'm using. I'm using RG316, and the feed line is good to 3 gigahertz. I did try standard Mini 8 coax with BNC adapters, and over here I'm adapted from BNC to in connector. With that said, the highest frequency I was able to get on Mini 8 was 1.212 gigahertz, and that was a stable frequency with a short patch cable. So I really wouldn't recommend going too much higher with a longer cable, or wouldn't recommend using a longer cable than that due to the inherent loss of the cable. That cable, you probably want to stop using it about 100 megs with any substantial length to it. If I try to go higher, you can see it starts to become unlocked. Here I'm at 1.309 gig, and here you see what's happening. Now it's very plausible that if I had more voltage, more voltage, more RF power, this would probably excite and do read. That's one thing I do need to get, is a wideband RF amplifier. Hopefully take care of that problem. But at face value, this is what I have, and this is what you'll get out of this device. Now, I wasted a lot of time on my preamble into this and onto this, longer than I wanted to. Let's go ahead and one other thing I wanted to test on this was the crystal oscillator. The crystal oscillator on this is only good for 3.5 megahertz to 16 megahertz. However, I was able to, with the crystals that I do have on hand, was able to get it to read, slightly out of its range. Let me change my view here. Alright, light back on so we all could see better, at least me. Crystals. It does not support these crystals. These legs are just too fat to stick in her hole. So don't try ramming your big rod in her hole. You're going to break it, it won't fit. However, it will take these crystals just fine, because got the skinny poles, and you need to have a long pole to reach deep into the slot there. Short little nubs have a challenge. You have to sit there and you have to hold it in there in the hole, and you got to wiggle it about until it makes contact, and hopes you get some kind of reading there. With that said, let's go ahead and test a crystal. To do that, you turn on your crystal oscillator. You go over here to range, and you keep flicking this until we get oscillator and kilohertz to illuminate, and you push run. This frequency here, this crystal is 3579.545. How many of us are going to remember that? Probably not. None of us. It's close. Now, if I take this crystal and we swing up here to my Sinometer VC45, and I put that on crystal, and let's see what it reads. Again, this is a 3579.545. So comparable. And for whatever it's worth, because I forgot to state this in the beginning of the video, all of my test equipment for this has been on, powered up for at least 14 hours today. So definitely everything nice and warm. It will take these little tiny crystals that you find in your CBs or crystal controlled whatever. This is a 10.670. I won't demo it on the Sinometer. Try not to waste too much time. Here's a now again, the maximum this says it's supposed to read is up to 16 megs. Here's a 17.685 meg crystal, and you see it reads. And the bottom of the spectrum is 3.5. Here is a 4.6. Here is a 17.898, I believe. And I think this one says it's 6. Let's find out. Yep, 6. Very cool. Do 2 more crystals and then we'll call that portion done. Here is a 10 meg crystal. So 9.72. Let's go ahead and walk this one up to the Sinometer. So we can see this is really close. Really close. I would still accept the readings on the crystals with no problems. Grab my last one. I think probably proving my point that the dumb thing works. I thought I had one that was out of range, and that's why I kept digging through them. Okay, this one has no markings. It's a mystery crystal. So 1.3. There's a 576. So one thing I really don't like about that, any of these crystal slot thingies, is if you don't have long leads on your crystal, you're kind of SOL. Alright, so we're done playing with the crystals now. Let's go ahead and wrap this thing out, conclude this video. My thoughts, my impressions of this frequency counter. For some reason I left that camera up high. This is my least favorite frequency counter, even after I fixed it. Let me address to you the things that I don't like about this, and this is a subjective, personal opinion. You may absolutely love your frequency counter, and right on, I support that. It may be your only frequency counter, and it may be the only one that you need. It does the job for you. Fat and happy with that. What I don't like about the frequency counter is the display. I wish it wasn't green. I wish it was a red. It'd be a lot easier to view. Now, the thought process there was to go ahead and pluck out and install new digits. Could do that, not a problem. Unfortunately, the filter that's going over this is also the same color as the digits, so it would be a weird color. That's problem number one. Problem number two, having direct light on the frequency counter and at certain angles makes it really hard to see. Now, my camera is pointing at an angle, and this is at an angle. My light is straight up. And you can see it's a little challenging, but when I moved, it changed the contrast. A little easier to work with. In my old office, on my old workbench, my light pretty much washed this out. I had to turn my light off in order to properly see the counter. It looks a lot better. As you notice, put it on, you get to see more of. Now, I reckon you could put a sun visor over it, and that would probably solve the problem. Another thing about it I don't like is the mains power switch is on the rear. I do not like that. And speaking of the rear, this is you can change it from 110 to 250. So there you go. Has this cool handle. Now you can stick it anywhere you want. I do like the handle, hides away. Have other devices that the handle flips over or under, and you just can't remove it physically off the body, and it makes it really challenging. It sucks. And then I think the last thing about this that I don't like, real quick about the power switch. I don't like any device that has the mains power switch on the rear. I want it on the front. People may stack items on this, may tuck it away like I do here. Frequency counter. Hey, check this out. I told you I like frequency counters, and keep in mind, this is not my entire collection. This is what is currently on my workbench right now. Frequency counter, frequency counter, frequency counter, frequency counter, and although it's designed for something else, it does read the frequency. So, that will read frequency as well. How exciting. Last thing about this I don't like is it's very lightweight. You need to put a brick on the inside to weight it down, or sticky feet or something to manipulate this when it's sitting on a slippery surface. You know, it slides all over the place. Even though it does have hard feet, it does nothing. Now, I also bought, I don't mean to make this video go long, but for a reason. When I did a video on my Syncor and talked about all of its cool functions and features, Don, I'm a junk collector, expressed interest and said, wow, that is really cool. I would like to have something like that, but they are kind of spendy. I get that. So I knew right then and there that I was going to take care of my buddy Don. Don has been so super kind to me and has given me a lot of stuff over the years. Give him back. So I went out and bought this little kit. Even made a video on it. Never posted the video. Welcome, jerk. Welcome to Jerk. I guess I should have said that at the beginning of this video. You know how a lot of people name their electronic workbench something cool? Well, I think Jerk works out pretty good for mine. I could sit here and say jerk all day long and you don't know what I'm saying. But actually, I think a cool acronym for this is going to be Jack's Electronic Repair Counter. Jerk. Kind of cool, huh? Remember, you heard that here first on VintageElectronicsGeek.com. I think I paid less than $5 for that. That's right, Don, you're worth $5. Ha ha ha. Got it all put together, very excited. Went to test it. It don't work. It partially works, but not 100%. There was a batch of these that came out with a bad PIC, this chip. The programming in it is bad. If you are versed in reprogramming, then you can fix that problem. I'm not excited to even learn. That's not me. So I surmise you could probably buy one of these chips already pre-programmed. There you go. But like I said, less than $5 for the kit. You know, it's not worth it. I'll harvest some of the parts off of this. The LEDs, of course. You know you're going to pay more than $5 for that. Switches, jacks. So unfortunately, Don, I had good intent. I can't give you that. It don't work. So instead, what I'm going to do, my friend, I'm giving you this. This frequency counter is yours, Don. I hope you like it. I hope it comes in handy for you. If not, sell it on eBay. I see them going for upwards of $100. Buy you something then that will excite you. So what I'm going to do, Don, is I printed out the user's manual on the device. It'll walk you through on how to navigate and work it. It's fairly easy, fairly simple. Just going through your buttons here. But there you go. I'm also going to print up my my truth table for you, and I'll do it in bigger letters black lettering for you. That way it'll be easier for you to see. I'm going to go through and relabel which one of these ports does what. I'll use my little machine to do things like that. I'll just put it on there. And if you don't want it on there, it's very easy to pluck off. So just take it off, mother plucker. I'm coinciding this video to go out on a day that it's supposed to be delivered. So Don, I hope you find this video. Don, I hope you find this gift a treat, and I hope it puts a big smile on your face. And again, from the bottom of my heart, thank you, my friend. I cannot express to you how happy I am with all the gifts that you've given me. You are a true friend, and if I ever get a chance to meet you, I'll buy you your favorite beverage or meal or whatever. It's all yours. Do a video if you like, and tell me your thoughts. Try it out, test it. If you hook up a radio to this, test the radio. Be very mindful of your RF power. Use a RF sniffer or something. I would imagine you could air couple. I haven't tried it. And that's it. So, good luck. And thank you to everybody who watched this awfully long video. And we will catch you in the next Test Gear Tuesday. Wishing it was Taco Tuesday instead. Thank you again. Have a great one.